Hello, family. Welcome to another episode of MathsFanatics247. Here we're going to be looking on a question taken from a past paper on functions. Okay, and this is suitable for both grade 11 and 12. Awesome. So they say in the diagram, the graphs of f of x and g of x are drawn below. The graph of f intersects the x-axis at B and C and the y-axis at A. The graph of G intersects the graph of the graph of F at B and S. PQR is perpendicular to the x-axis. Okay, with points P and Q on F and G respectively. M is the turning point of F. Okay, so ladies and gents, let's get straight to it. So, the first thing that I want you to do before you do function is this. You are going to highlight these points here. So you see B and C are the x-intercept of the parabola. So I highlighted them, right? So you're always going to highlight the important points, okay? And then turning point M, I highlighted, right? And then point of intersection, this is where the graphs are equal. So in this case, f of x equals 2 and g of x are equal there on the point of intersection. Does it make sense? Of which in this case, they meet here and there, right? Awesome. So we highlighted that. Then in this case, there's no asymptote. Remember, asymptote is only for hyperbola and exponential. And then horizontal and vertical lines. So they told me that this line is perpendicular to the x-axis. When a line is perpendicular to the x-axis, it has to be parallel to the y-axis and vice versa. So because this line is perpendicular here, it means it's a vertical line. What do we know about vertical line is this. The x value here, the x value there, and the x value there will remain the same. It will not change, right? Perfect. So now we can easily solve the questions after planning, right? On 6.1, they want us to determine the coordinates of A. If you check A, this is your y-axis intercept. So we call it y-intercept. So obviously, we know that on y-intercept, we make what? We make x 0, right? And then this is f of x. So wherever f of x is, I'm going to put 0 there. We substitute 0 on x's, right? So we're basically looking at f of 0. When x is 0, use brackets to substitute. Plus 5 is 0, plus 6. The answer is 6. Therefore, A equals to 0, coordinate 6. Okay, perfect. So now we can go to 6.2. So 6.2, they say, okay, let us show here our A was 0 and 6. Then remember, actually, a y-intercept, you don't need to show the working out, right? The last number without a variable, so a constant, basically, it's always your y-intercept for a parabola and straight line, okay? For example, by the look of things, seeing that is 1 there, I can already tell that this point here is what? It's 0, coordinate 1 for a straight line. Okay, now they want us to, S is the reflection of A above the axis of symmetry of F. Remember, axis of symmetry is basically the line from here, from the center, going down there. Do you get it? Going down there. Awesome. So we need to know basically what is the value of this line, right? We need to know the value of this line. Perfect. So now I'm going to find the equation of the axis of symmetry. Axis of symmetry is basically x value in turning point. Ne? So if the questions say calculate the equation of axis of symmetry, you just do the x value in the turning point, which is negative b over 2a. And then by the look of things, I have f of x equals to negative x squared plus 5x plus 6, right? My a is equals to negative 1. It's here, right? There's 1 here. And then my b equals to 5. My c equals to 6. Okay. So I can easily get the x value on the turning point now. My negative and then 5. Then I put 2 and then a, which gives me 5 over 2, right? Perfect. So now, remember on S, since it's the reflection above the axis of symmetry, it means the y value is not going to change here. The y value there must be the same as here. So I already know that the y value is there. No? But I know that this x here, which is 5 over 2, cuts the graph into 2 equal parts, basically. It acts as a mirror. That's why it's called axis of symmetry. Cuts the parabola into 2 equal parts. So the distance from here to there will be the same as the distance from here to there, right? But here I have 0. Here I have 5 over 2. So which means the distance from here to here is 5 over 2, right? So which means this side I must also add 5 over 2, which makes it basically, let's see, 5 over 2 plus 5 over 2 is going to be 5, right? It's going to be 5. Marvelous. So which means this point there is 5 coordinate 6. Perfect. Now they want us to calculate the coordinates of B and C. If you check, B and C are the x-intercept of the parabola, right? So what do we want to do? Remember x-intercept? So 6.3. X-int, we need what? We need y to be 0, right? So I'm going to make this part 0 now. So 0 equals to x squared negative x squared plus 5x plus 6, right? When you're here to get your answer, you have an option of using quadratic formula. Ne? You'll still get your 2 answers if you use quadratic formula. Your A is that, your B is that, and then your C is that. But I'm just going to use factorizing of trinomials. So I'm going to switch all signs first. So that is 5x minus 6. Okay? So you take this number, which is 1, you times it with the last one. What does it give me? It gives me negative 6. Then I'm going to look for 2 numbers. When I multiply, they must give me this. When I add, they must give me that. Okay. It's pretty simple. I know they go in pairs. So 1, 1, 6, 6. Then I have 2, 3. I have 2, 3. So this one can be there, so that when we multiply, we're getting in the negative. And then I need the 2 that when I add, they're going to give me negative 5. So obviously, is this one's, right? So 0 equals to x minus 1. I mean x plus 1. Sorry. And then x minus 6. Then when I get x plus 1 equals to 0, or x minus 6 equals to 0. Therefore, x equals to negative 1 or x equals to 6, right? And then you're going to decide now which one is B, which one is C. So I see that B is the smaller one, C is the bigger one. So the bigger one is 6 in this case. So here we're going to have 6 coordinate 0 for C. Then for B, we have what? Negative 1 coordinate 0, right? Of which makes me happy now because I have 1, 2, and 3 points, okay? So let's move on to, so this is done, that is done. Now we need to do 6.4. If the distance, remember if they say this, PQ means distance between P and Q equals to 5 units, we need to calculate the length of from here up until here. So from O to R. Okay. That should be fine. So this is what you're going to do, guys. Né? PQ. So you check. P is at the top. Q is at the bottom. So this is f of x. This one here is g of x. You agree? Perfect. You always going, so they are looking for this distance here. Né? It's easy. We are always going to take the one at the top minus by the one at the bottom. Né? So you're gonna see top minus bottom. I mean bottom. So the top one is f of x in this case. You agree? The one there, it's f. The one that is above, it's f. So we're gonna say f of x minus g of x equals to 5, right? And then what is this? Let's check. So here, f of x is negative x squared plus 5x plus 6 minus g of x, x plus 1. Don't forget to put a bracket here when you're minusing with more than one term. Okay, they say the answer must be 5, right? Then I'm going to simplify now. Negative x squared plus 5x plus 6 minus x minus 1 minus 5 equals to 0. Negative x squared. This 5x will add with this one to give us a positive 4x, right? Then this one and those other ones, they were going to cancel. Né? So we get this. Then here you can use quadratic formula. Your a is negative 1. Your b is 4. Your c is 0. But that will be a long way. There's a short way of doing it, which is x, a common factor. So here I'm left with negative x plus 4 equals to 0. Then I created two brackets. I can now separate. So x equals to 0 or negative x plus 4 equals to 0. So I'm going to move the negative x that side. So I have 4 equals to x, right? Perfect. But obviously, I see that there's no way x is going to be 0 in this case, right? Perfect. So which means that what this tells me here is the distance from here to there, it's also 5, which is true because 6 minus 1 gives you 5. Do you see it? Perfect. So now, remember the x value here, it means the x value from here to there, it's 4. Né? So which is the distance from OR basically. Therefore, OR is 4 units. Do you see it? Then finito. Now they want us to calculate the coordinates of M. Remember, M is the turning point, right? And previously, we calculated the x value in the turning point, which was, so we're doing 6.5.1. The x value in the turning point was 5/2, right? Now we need to look for f at, remember I have the input, I can get the output, which is the y value. So I'm going to look at f at 5/2, which is equals to, on my parabola, wherever I'm seeing x, I'm going to input 5/2. So I have a negative. Where there's x, you open bracket, you put 5/2. Then there's a square there. Then I have plus 5. And then I have x. Where I see x, I open a bracket, I put this. Then I have plus 6. Then now we can press this on a calculator to get our solution, right? Let's see what our calculator gives us. So I have negative 5/2 squared, squared plus 5/2 plus 6, which becomes 49/4. Okay, 49/4. Therefore, this is the y value, that is the x value on M. So therefore, M is 5/2 to coordinate 49 over 2. I mean 4, sorry. That is our final answer for M. Okay. So, ladies and gentlemen, let's do the last question. Awesome. They want us to calculate the maximum length between P and Q. Remember, I said P and Q is here, and P is at the top, which is on the graph that is on the top here is the F. So PQ is given by f of x minus g of x, right? So we're going to now substitute negative x squared plus 5x plus 6 minus x plus 1, which becomes negative x squared plus 5x plus 6 minus x minus 1. This is the length. So negative x squared, so plus 4x, and then plus 5. No? Perfect. So this is the length in terms of what? In terms of x. Does it make sense? Perfect. So like for example, what was the distance? If I put 4 here, right? My answer is going to be 5 because they told us that the distance is 5. And if you substitute 4, you're indeed going to get 5. Ne? So now we're going to look for x values that are going to have a maximum. Ne? There are 2 ways. I'll show you both ways. Ne? I'll call this one way 1 and then way 2 then. Ne? They should give you the same answer both ways. Ne? Guys, remember, this is a parabola, right? Ax squared is always a parabola. So I'm going to find the turning point here. Remember, this is the parabola that is facing down. You see, is the parabola that is facing down. Ne? So obviously here I'm going to have the maximum value. So my maximum is basically the y value in the turning point. You get it? So I'm just going to do turning point using the. So I can see that my A is negative 1, my B is 4, then my C is 5. Okay. Remember, axis of symmetry is negative B over 2A, which is negative 4 over 2 negative 1, which is 2. Now, this is the x value that is going to give me the what? The maximum. Ne? I have to input it into my distance formula, which is there. Remember, this is a representation of distance between P and Q. So if I substitute an x value, I'll get the maximum distance because it's the turning point. So let's do that. I'm going to do it here. So PQ, maximum distance, going to be negative 2 squared plus 4, 2 plus 5, which becomes, this is negative 4 plus 8 plus 5, which becomes 13 minus 4, which is 9. So your maximum distance is 9 units. Ne? Okay, way 2 of doing it is using calculus. Remember, for minima and maxima, the derivative must be equal to 0. Ne? This way, you can only do it if you already did calculus. If you haven't done calculus, you'll always need to use the turning point method. Ne? Remember in calculus, we take the exponent, we multiply the coefficient, which is negative 2, and then we minus 1 from the exponent, which is x. Then here I have x to the power 1. When I multiply 4 by 1, I get 4. And then x to the power 0, which, okay, x to the power 0. The derivative of a constant, it's always 0. Ne? The derivative of a constant, it's always 0. So here I have negative 2x plus 4 because x to the 0 is 1. Negative 2x equals to negative 4. Then x equals to 2. You see? And then you're going to now follow the same step and substitute into the original distance representation to get your thing, your maximum distance. Ladies and gentlemen, just like always, please remember to advise your friends and families to subscribe to this channel, and also tell them to advise their friends and family to also join in the process to perpetuate. If you haven't subscribed as well, please kindly hit the subscription button for more content like this. Danko.